students at least. So I would like to say a few words why we did it. As a matter of fact, during the monsoon season, as monsoon fluctuates and there are always questions. So every evening around this time, we used to meet there, and there was a coffee cup club there. We used to discuss among the faculty. So at some point, somebody said, "Why are we discussing informally? Let's meet here." And so that's how it was born. The idea was also related to what I had discussed this 20 years ago. Almost all science departments where there is research going on, there's a journal club where students meet regularly to discuss the latest papers. Somehow that tradition is not there here. I tried to start it, and Francis started it, and after he left, it fell down. So I still suggest that it's very important to have a group of students doing research to continuously interact with others, find out what is going on, because the subject is exploding like anything, okay? None of us can keep track of what's going on. So it's important that you meet occasionally, and in this forum or some other forum, to exchange notes about what is the recent development in the field. Okay? And just to give you an idea of what's happening, just this morning, as I was preparing for this talk, I saw two papers in one journal. Okay? Just one journal, two papers. Okay? And both are very interesting. One is the influence of monsoon low pressure system on South Asian disasters and implicate disaster prediction. There's one of the authors is Booz, who was invited here to give a Grantham lecture. And what is amazing is he has used data on disasters from India, which is available on some website which I didn't know. So what I wanted to tell you is that a lot of data available, and there are people outside India using it. We're not using it because we're not aware. Okay. So this is a very nice use of data to show how, and he has one picture I've taken from the paper. I didn't have much time to look at it. And you can see he's discussed two low pressure systems which went from Bay of Bengal all the way to the Arabian Sea. One in 2010, which caused floods in Pakistan. One in 2017, which caused floods in Mumbai. Okay? And it shows how the low pressure system has impact going into about 500 kilometers on either side. Okay? So this kind of work is interesting, and I hope one of you will read the paper and present it, a short presentation. Similarly, there's an interesting paper on land after feedback, how it causes crop failure. And this is a very important issue for India. And this interesting paper, interestingly, again, I glanced through it, I didn't go through in detail. They don't talk about any failure of wheat or rice in India. They talk about soya bean. I don't know why. If anybody knows something, they can tell me why wheat and rice. My gut feeling is wheat and rice are irrigated, so monsoon failure doesn't bother you. But maybe soya bean is some other crop. I don't know. Somebody can enlighten on that issue. Okay. So what I'm going to point out is that because of the available data very freely now and available in proper computers, the number of papers related to our area is just exploding. There is no way you can keep in touch unless you interact as a group. Okay. Now let me tell you what happened in 2015 when we started. Okay. Very interesting start. When we started 2015, this El Nino was developing. Early 2015. This massive warming of the East Central Pacific. This started in early 2015. Okay. And there was concern from the government side, new government had come, you know that. So the concern, because 2014 was also poor monsoon year. Now, two consecutive monsoon failure is not good for this country. That affects many things. So people are concerned and wondering what will happen. Now, just for those of you who are new here, we are going to talk a lot about this Nino 3.4. This is the region of the Pacific which has global impact on weather and climate. So, we'll focus on this, but remember that 56 years ago, when we didn't have data over the ocean from satellite, we were relying only on this region, you know, 1.2 across the coast, because Peruvian fishermen used to go around here. They are the ones who discovered El Nino. Because in late December, they saw some sudden change in temperature, and under the time of Christmas, so they called it the child. So that's how it came. But remember that this does not have global impact. This is a global impact. That's why I'll focus only on this in this talk and future discussion. Now, for those of you again who are new here, I strongly recommend you read the beautiful book by George Philander on our El Nino. It's a wonderful book. It is not a technical book. It's a popular book written with great spirit. And just give you a list of chapters. See the title he has given. perspective of painter or poet or musician. So here's a very broad this one, and so please read that to get an overall idea of why El Nino is such an important phenomenon. Okay. Now that year 2015, this is the phase diagram which I like very much. This is the warm water volume in the Pacific. It tells you how much heat is stored, which will come out in the next 6 months. And this is the temperature departure in that 3.4 region. Okay. And look what happened in 2015. Starting on January, February, March, April, suddenly started rising rapidly, exactly like this year. This year, in January it was minus 0.6, then 3.4. Now it's gone to plus 0.6 just yesterday. Okay. So we are on the same track as this. So to me, there is an extremely high probability of a drought this year. Now, in 2015, India met about something which was unheard of. India met about has been forecasting monsoon for almost 100 years, okay, from the time of Sir Gilbert Walker. And they use statistical method, which gets the mean right, which will not get extreme right. Anytime you fit any set of points to a line or a curve, it only fits with the mean. Okay. So they always used to take normal rainfall. We used to laugh at it, okay, 40 years ago. And this went on, and then there was some big failure like 2002. Was a huge drought and they couldn't predict it. So then they decided to adopt a dynamical model, which they have done for the last 10, 15 years. But I can tell you, in spite of the great progress in computers, in our understanding, the models are not that good yet for predicting monsoon, drought, or flood. Okay. Now, this is a great disappointment for me personally, because 40 years ago, I switched over from mechanical department to here, thinking that with the availability of computers and my knowledge of film heat transfer, we can solve the problem. It's not possible, okay? So as you study this, more and more you appreciate how complex it is, and that's very challenging. But you cannot always solve the problem completely because it is a complex nonlinear system. Okay? And that's why people are now clamoring for machine learning and AI, maybe to solve it. But my fear is, as is fear all over the world, AI and machine learning may give you a solution. But you don't know whether right or wrong, because it's a black box. So the job for most of you here who come to do PhD and research is to understand the physics of the monsoon, not just produce an output. Okay? Output a machine can do very easily. Machine cannot tell you why that output is correct. So the biggest challenge here today on all of you are facing it, you run a model on a computer, then you spend 3 years figuring out what happened, because it doesn't tell you why that answer came, right? So that is a challenge. So what happened in 2050, for reason why I really don't understand, IMD made a prediction the rainfall will be well below normal. Okay, this is 84-92 means 88, 12% below normal is a real drought. All of us are surprised that they made the prediction because they never did that before. So somebody took some courage and made a prediction which done. On the other hand, the private forecasting firm for climate, which had just come in, they thought they will make a different prediction. They said it will be normal. Okay. And you can see this distribution also, but not just mean value. The distribution is that IMD said there is 93% chance that the rainfall is below normal. 93%. Okay, that's an amazing prediction. And so they were nervous because one could go wrong. They're not a perfect science anyway. And only 7% chance of it being normal or above normal. Now, what happened? Monsoon, it developed in its own way. June and July were close to normal. Okay. So SkyMet, being a private company, was jumping up and down, putting out this one. I'm told, they told the Prime Minister, see, we are better than this big department. They have 1,000 people, we are just 5 people. All this went on, all this criticizing of including all newspapers you can see at that time, they made fun of IMD, saying that you see, they made a drought prediction for the first time and they're going wrong. Okay. Then what happened? August, I think around 20th, Prime Minister Modi called a meeting of all the scientists. And why was there that meeting? And in that meeting, he openly criticized the Secretary of MOES, saying, you have predicted drought and it's normal till now. What's the problem? The Secretary was very polite and didn't tell him that he said, please wait, there's some more time, also not over yet. Okay. And it turned out, after the meeting was over, after that, there was a series of breaks and we had a drought. So that's how that thing, this one. And as a matter of fact, I must give credit to SkyMet. although they are not a great forecasting agency, at the end of that season, they were very good in PR, which government doesn't have. So the guy got a very nice letter congratulating IMD for being correct prediction. So that is smart move. He made a mistake, he didn't want to say it. He said, I congratulate IMD, good prediction. So he maintained good relations. And irony is, Skymet consists of mostly retired officers of IMD. That's the interesting point. Okay, now this is a typical example of a forecast by IMD and the actual forecast is in red, actual in blue, clearly showing that the forecast is in a too narrow region. It cannot get drought very easily except in 2015. But in 2015 it got it right, this one. That's the time it got it wrong. So tell you that this is a challenge. Predicting the mean is easy because it's mean most of the time. Predicting extremes is the challenge. Both for dynamical and statistical. Now here is a summary of last 9 years, 8 years of discussion I've had, and you can see we went through various things. For example, in 2015 I talked about it started well, then it became very bad and became pretty low. Next year was La Nina. IMD was very excited by the success in 2015, so they made a prediction to be flood year. Okay, they went wrong. Okay, this is what happens. Next year was the La Nina. Everyone thought it would be above normal, but it was barely just below normal. As a matter of fact, Professor Salona Gargiel has a paper now recently published on why certain La Ninas do not cause floods. So there is an interesting hypothesis on it. You can read about it. Okay. Now you can see that the unusual year we had 2019. I predicted normal rainfall, and it was well below normal in June. July was okay, August was okay, and suddenly in September it just went twice the normal, and we had a flood year. Okay. So that was very difficult, but that late phase of the monsoon became very vigorous. Now last year was also a good year. As a matter of fact, 1, 2, 3 of the last 4 years have been well above normal, and so this year, the fact that El Nino is developing, there's a very good chance that it will be a drought. But let's see what the forecast of IMD was. Okay, now just want to mention that why 2015 was so critical was in 2014 when there was a drought, the efficiency in yield was pretty high. Many crops, including soybean, which I mentioned, 90% below normal. So soybean obviously grown in rain-fed region, obviously, is 90% below normal, and so this was what the ministry was concerned about. That there's not one more drought, but it happened. But I tell you one thing: India's economy is not that dependent on anymore. Hardly 15-20% of GDP comes from there. But the real reason why politicians are worried about drought is politics, not how our country is employed in agriculture. The agriculture phase, that's a huge problem for those who do not see, you cannot see, they will see. And if you're a politician, you have to win votes, you have to be careful. You have to worry about that. And of course, the world is concerned, because whenever there's a major drought in India, to consider year, India goes and buys wheat and grain in the world market, world price goes up. Okay. So this is one of the, I'm told that many agencies in the world, not just the department, CIA in America, they'll make a secret prediction to the government, what their forecast is, so that that government can start being ready for inflation of price of wheat or rice. So it has a global impact, remember that. Okay, so here's what happened in 2015 July. I told you, so it's close to normal. That's why Skymet was celebrating its prediction, but then it went wrong later. Now let's look at forecasts made by both statistical model and dynamic model for the last 10 years here. And you can see that that year was very good because both models agreed, so they were confident. Next year also both models agreed, but they were wrong. And again, they were wrong in 2019 when a huge flood. And their prediction for drought was not so good in 2018. 2020 was okay, 21 was not bad. So that is the rate of success, not perfect, not surprising. It's a complex system. You can't expect to be right all the time. Now just look at the statistics of that phenomena. If you look at the last 160 years of data, there were 24 drought years, 30, 40 years, that is about 10% below, that is below 90% and above 110. And of the 24, only 14 were El Nino years, okay, and hence droughts. There are 10 years were not El Nino years, but be careful when you read the papers. Very often, when people out in India write papers, they quote El Nino value in December. But December is irrelevant to India. If this year the El Nino doesn't develop in the next 3 months, but peaks in December, who cares? Once September is over, we don't care for El Nino, right? But people don't realize that they always quote El Nino, but that's a peak of El Nino always, seasonal cycle. So many people quote these 6 years as El Nino years, but as far as we are concerned, that El Nino did not have impact on the drought. So there are 10 years in which we do not we have drought without El Nino, and recently I think Priyanshi and Arindam have a paper on that, comparing El Nino drought and non-drought, and I think Arindam will present it sometime in the coming months. Okay, and there were 3 El Ninos that were not drought, so that is also interesting. So we hope this year will be that year. That's the hope we have. Okay. The years we want to look at those details. Okay, now the other thing about El Nino and monsoon is very interesting. If you look at the correlation between JJ's rainfall and the SST in El Nino 3.4 region, 2 years ahead and 2 years later, there is hardly any correlation just before the monsoon. That's the big problem. We want to know around March, April what will happen to the monsoon, we can't predict it. But as the monsoon develops, the correlation goes up and it peaks after the monsoon. So this was meant by many people to say that monsoon controls El Nino and not vice versa. Okay. Now this was mentioned by many people, or what Webster would call mutually interacting systems. That is, monsoon is not into El Nino, neither El Nino into a monsoon. But more and more evidence is gathering that El Nino is an independent quantity by and large. The effect of monsoon El Nino is not that clear. We'll see why. I'll talk about that briefly. Now, this is the paper we discussed last year. I think Rajat is here, right? Yeah. So we discussed this last year that in meteorology, because lots of things vary in time, and we do correlation to find out how they are connected. Okay? But correlation is a very deceptive quantity. Just because something is correlated doesn't mean it is physically connected. Okay? Correlation can happen by accident. So then people thought, fine, correlation not that good. Let's do lead lag. Let's see, there are 2 time series, which one leads and lags, that'll tell us something. Yeah, it will definitely both things. But even that doesn't guarantee. Now, that was not known to meteorology for a long time. Okay? But this was known to economists. Economists are being a certain more complex than us. See, in our field, meteorology will feel at least on the day-to-day and intermittent variation, I don't even think they have an impact. But of course, 50 years from now, we are going to have an impact on monsoon and climate. But on international scale, we don't think we are having influence. But economics is a subject which is wholly controlled by human beings. Okay? Very tough subject. And so lots of people have spent time on it, won Nobel Prize for it. And I remember even now, after so many years, that in my course in economics I studied in IIT Madras, there's a book by Paul Samuelson, famous guy. He said one statement I liked him. He said, the reason why economics is so difficult is because you cannot put emotions into equations. Wonderful statement, okay. People's response cannot predict it. All the politicians know it. No election can be predicted correctly. You never know what people think. So that's the problem they have. In spite of that, they work a lot. They have lots of quantitative models and worked on it a lot. And one of them was a famous guy called Clive Granger. He won a Nobel Prize for this idea. There are 2 time series which seem to be connected. Okay, that is, we want to predict y given x because you think that x is causing y. He said, put down an equation there. You can have this is the lag. You can put any number of lags if you want. And his argument was that you use an equation and demonstrate that the effect of x on y is greater than effect of past y on y. Because remember, past rainfall also affects rainfall. Past temperature affects present temperature. So a lot of autocorrelation over long time scale. So a lot of people have made mistakes in this field because they don't recognize the fact that SST is varying in time, rainfall is varying time, you may see a correlation with the leak lag. It doesn't prove anything. Okay. If you want to be rigorous, you have to do what Granger suggested almost 43 years ago. Sorry, 1969. That will be 54 years ago. Okay, for which he got Nobel Prize. So this is a paper he wrote in Econometrica, and so this is a nice one which Rajat discussed how that was applied in meteorology later. Okay. Now let's come to this year's El Nino. We have been having a long period of La Nina for about 3 years, and it's a matter of time. It cannot go on very long because in these 3 years of low temperature, the ocean has been gaining heat. And the heat is stored heat is going up every day. At some point, it has come out. So today, this year has come out rapidly. It just went to 0.62 just 2 days back, and it's going to exceed 1 very quickly. Now, it's very important for us how high is the during June, July, August, September. That is the period we are concerned about, and looks like it's going to exceed 1 and be well beyond 1. Now, if you look at the phase diagram between warm water volume and sea surface temperature, this is last year, this is going around in circles, and this year it took off. But all the heat that is stored is trying to come out, and this will go like this over the next 1 year. Okay. So it is clear that there is going to be warming. The only problem is how much warming. That's the only issue. Warming is guaranteed. There's no doubt about that. How do we know that? From these coupled ocean observer model, all of them are predicting based on this April condition. All of them are saying good warm. Only problem is some of them are saying 3 degrees, some are saying 1 degree. That's the problem. And that's important for us. If it's 3 degrees, you're going to have a problem because they're one of the hottest El Nino ever, comparable to 1998. But it's also about how rapidly it gains heat. We are concerned about this. In this period, you want to know how warm it will be well above 1 degree or just about 1 degree. That is critical for Indian monsoon. Okay, now people have written a lot of coupled models over the last now 40 years. And the most famous one is the Mark Kane model, and he ran it for I think what 160 years, and it looks very impressive. Here I forgot the color bar. I'm sorry. I think I should have put the color bar here. Color is mentioned here, it's not mentioned. So one is model, one is observation, and you can see that agreements are quite good, except there are years it fails. Okay? There are years it fails, and that's the problem we have. For example, today in the last few years we discussed this in this forum. There are machine learning techniques available now. Okay? Now, trouble in machine learning in our field is we don't have enough data. Machine learning is wonderful, image processing, marketing, where a lot of data is no problem. But in our field, at the most, because of monsoon, we have 150 years of decent data. With that, it is difficult to both train the model and test the model. You can see any number of people, they train for 130 years, test for 30 or 20 years, then it's not reliable. Okay? You're lucky you got it right. Okay? So it's a tough problem, but some of these guys are very smart. One of them is the South Korean Ham. So he used the data from a coupled model to train his machine learning. That's smart move because coupled models can run for 1,000 years, 5,000 years, 10,000 years. But you have to make an assumption that the coupled model is realistic. Now that is not an assumption we can be 100% sure. Because in spite of the remarkable progress that is made in coupled modeling, still the SSTs in many models have bias of 1 or 2 degrees. They corrected when they view results. They are 1 or 2 degrees too low, and that's why it matters. Because that controls the operation, controls so many things. So it's a nice idea to train your model with coupled model data, but you can. So what happened? Last 3 years there have been papers on machine learning. I'll show one of them as a result. Now this is the one which is very important for understanding. This is in this case blue is SST and red is the bomb water volume. And what it shows clearly that the change in SST follows the change in bomb water volume by about 3 to 6 months. So we have a fairly good idea for the warming will occur, not just by looking at bomb water volume, which is a quantity easy to calculate. But we don't know how much. That is the problem. Okay. Now here is an example of an excellent prediction made in 1997-98 El Nino. I am really impressed by this because not only they got the 3.4 right, they got the whole pattern right. I mean, that is again, party luck. I don't think it'll always happen. This guy got the whole pattern over the present question, almost right, with a few exceptions. So I want to read this paper and try to figure out how he did that well. Okay. Then for students, I want to remind you the excellent review paper by David Nealon, published almost 30 years ago. Excellent paper on why n is so difficult to predict, because it's chaotic. The chaotic system, we have looked at it in great detail. So those of you who have taken courses from Ashwin can go through this and see how chaotic system understanding can improve your. So this is what shows why it is difficult. Now let's look at the prediction this year. Almost all the ones are saying that by June, July, August, there is 90% chance that it will be above point. It's already above point anyway. So it will continue to be like till the December part. Okay. So both parties agree on this. And the only question now is how one can say probability. So June, July, August, which is what concerns us, can see there is 30% chance it will be very strong, that is about 2 degrees, or between 1 and 2, or between 0.5 and 1. That's what there is an uncertainty. Everybody shows that it's going to be, and you know how strong El Nino is what we are not able to be sure about. Okay, we are all concerned about this because we plot the June, July, August, September temperature anomaly, 3.4 with monsoon rainfall with a famous picture, shows clear result. But note that once it is above 1 degree, there is a large spread, including the famous 97, which came close to normal. So there is a large spread, including the 94.1, which was influenced by Indian Ocean. But by and large, you can see that as you go to higher temperatures, there is a very good chance will be here in this region. And that's the challenge to understand under what conditions that will happen. Now, Arindam published a very nice paper, I think 2 years ago, right? Paper is 20 and 2 years ago, 3 years ago. So in which he classified not the 3.4, but the transition from last winter to this summer. Okay. Now we are going from La Nina to El Nino now. That's very clear. Now, according to Arindam, that's purely based on data, no modeling. There were 9 such years. No year was excess. 1 year was normal, and 8 were drought. 1 year is 97, right? Yeah. So 8 were droughts. So just going by this, I would have advised IMD to predict a drought. Just going by this. No physics, no understanding. Past data actually shows when you go from a La Nina to El Nino, the chances of drought is almost 90%. But I would like to know why they did not do it. It's a mystery to me. Now here is the prediction by Indian Met Department, which was updated just 2 days back. So they are saying it is 51% chance below normal, 49 above normal. Essentially, it is normal. That's what they are saying. I don't think they are right. Okay. I may be wrong. Doesn't matter. We'll see as we go along what happens. So I don't know why they did it because as you'll see later, I'm going to show the forecast of the model used by IMD CFS V2, whose output is not directly availability, but my student Rajendran, who is in Fourth Paradigm Institute, that is on his GMAX, he ran the model here and he gave me the output today. So I'll show you some results. It is very bad. Maybe CFS is wrong, we don't know. But this looks very, very. But you can see that compared to normal, 33%, this is 51. So slightly above normal sort of drought, and this is almost same, and this has come down from 33 to 24. So that has shifted that much. But considering all the background, to me this looks too optimistic. Yeah, we have slightly updated it at the last focus in April. In May, not much change. 45 and normal has gone up compared to climatology. Okay. So remember, this is the new system they have called tertile. Bottom 1/3, top 1/3, and the middle 1/3. So that's how they split it. And so they are saying this is going up, and this is slightly lower than the previous forecast, but still close to normal. And these are predictions for various parts of India. We'll see that later. At the end of the this monsoon season, we'll discuss how good their forecast was. okay, for each part of India. Now, this is the spatial pattern. I'm sure this comes from CFS V2, and you can see that it is pretty bad. But remember, this is a qualitative forecast, not quantitative. And in a way, I understand that we know that quantitative forecast is tough, not easy. So might as well be smart and do qualitative. All they're saying is this will be below normal, but not how much below normal. Okay, and this is above normal, Karnataka and Kerala. Let's hope so. Get an early here. And Northeast normally goes out of phase, but not really that much. Okay? And most of central India, there is no signal. That is about normal. Okay. And this forecast of IMD, you will see later on, is similar to all other forecasts I'm going to show you, hardly any difference. This is CFS V2 as run by NSUP in America. This is July, August, June, July, August, so September is not given. And they given millimeters per day. I like this, it's quantitative. It is very large. The average showed somewhere 2 millimeters per day below, which is very large. Remember that average monsoon is 7 millimeters. You're 2 millimeters below, you're finished. There's going to be a huge drought. But there's only one model, they could be wrong. I want to notice interesting structure here, bimodal structure here. This is low, this is high. Now, this indicates, for reasons you don't fully understand, that due to the El Nino phenomena, this region will get more rainfall, and this will get less at the expense of this. Now, this is quite common to El Nino here. Essentially, the system moves to the right. Okay, I can plot various El Nino years. The rainfall anomaly, overall anomaly, it clearly shows shift to the right. Most of the time, not always. So that's what this is showing, and it is already evident right now that is beginning to happen. Now, another model is North American multi-model ensemble. All the models use North America, very similar to the previous one. Again, a very nice diagram between East Asia and India. Okay. Of course, this is below normal. Well known. Remember that the cleanest signal of El Nino in the world is in the Indonesian region. The El Nino in Indonesia definitely has a drought, 100%, no problem about that. It is only off the equator we have a problem, because around the equator, due to the trend temperature, air rises over the Southern Pacific, it sinks over Indonesia. No problem, that's very easy to understand. But off the equator, there are all kinds of vague theories in the published papers. None of them are believable. Okay. They talk about how Walker causes the Hadley to change. All this is hand waving. There is no rigorous proof as to how El Nino affects Indian monsoon. There's only correlation. As I told you, correlation doesn't do anything. Okay. Let's see other one. This one is I think this is for June by India Multi Party. Now June, most of India is very normal. And that I'll talk about why. Because the onset is already delayed. Onset is supposed to be tomorrow, but it's not happening tomorrow, not happening next week. It's probably happening around, Arindam says around 15th, right? Are you going to 15th? So remember Arindam prediction. Let's see how he comes out right. Okay, now here is the result from the CFS V2 model, which is run by Dr. Rajendran in 4th Paradigm Institute, and he gave me the data, and he has run this condition of 1st May, 6th May, 11th May, April. So April, May time, okay? And you can see the huge variation between different numbers of the model. That means the system is pretty chaotic. So right now we cannot say it will be either 3.5 or 1.5. Cannot say that. That's the problem with the model. Models are still, because going through the space of April, May, most models will show a lot of spread, unavoidable. Okay. Now, here is the result which really bothers me. This is the prediction for June from 4 members of the ensemble, which were initialized on 21st April, 26th April, and 6th May. Okay. Now, what this is clearly showing, except one case here, all are saying that the IT season is going to hang around the tip of India for most of the June. Okay. That is remarkable. I never seen this before. if it happens, June rainfall will be well below normal. Okay, but IIT is saying this will be normal. I don't know how. Only possibility is, which I'm not ruling out, that once it comes around 15 June, as Arindam predicts, then after that it pours like crazy. Okay? Extreme rainfall. So this possible in this era we're living in of climate change, global warming, it's possible that a lot of rain will occur in the next 15 days, well above the normal to make up for the lack of rain. Possible. So you have to watch out for that. So as you go along, we'll see that this forecast is true or not. Okay, how about July? July also is equally bad. Again, the IPCC is hanging around the tip of India. Okay, and this is very nice, clear indication of where the IPCC is, and most of India has nothing. So we hope it's not true, because this is, if it is true, it's going to be, see, July is the most important month in the monsoon, the peak rainfall month. If that goes down, recovery, August might go a little bit, but it's too late. Okay. This is what happened in 2002, I remember that. 2002, we had one of the most serious, 50% below normal rainfall in July, which is unheard of. There's only one in the last 150 years. Okay. I hope it doesn't happen this year. Now, reason why I'm very, very concerned about IMD prediction is, if you look at the all the El Nino years in the last 61 years here, except for 97, which was the exceptional year because of IOD, Indian Ocean playing a role, all of the mean value of the deviation was 150 millimeters. Mean value. So I don't see how this year, unless it is like 97, how this year cannot be a drought. So again, you can add up all the numbers here. You can see that probability of this is very, very low, but not impossible. So this year, what is Skymet forecast? Skymet was not very sure, so they forecast 94%, which is technically a drought, because not 95. But they're not predicting a very serious drought either. Okay, so we'll discuss that because they make prediction for every month here. This they will go wrong definitely, I think. And 95, 92, and this is interesting. 90. See, as the El Nino develops, September is going to be a month with very severe deficiency. Almost guaranteed. If it happens, it will happen very severe. So they have used that data carefully, but I'm not sure about these two. So we'll discuss that as we go along, how these things come through. Now, there's one more prediction here. This is from Japanese, Jamstack. Okay? And I find it interesting because they seem to indicate again that I think this is like a hover around Indian Ocean where we got, but they're saying normal over India. So that is a bit surprising. And they don't get that high rainfall over East Asia. They don't get that. So these are subtle features which run on the model, and we're not sure who's right. This is okay. If you go to the off equator, it will go down. That's very simple and current is true. Okay, one more forecast. This is the South Asia. Ravi will know the error name. This is what is it called? SASUF, South Asian something, right?
Yes, SASCOP.
SASCOP, yeah. One of the group of Asian nations who make a prediction. Again, they are very similar to IMD sometimes, except that they give a little more rainfall over Orissa compared to others. So we keep all that in mind when we start looking at actual evolution. Now, this interesting prediction by Suman Dekam, who is in the University of Maryland, Arindam gave me that forecast. This based purely on SST, no model. You look at how SST is developing in the last 4 months, and then look at the past data, surgical fit. Okay? And he's also saying pretty bad for India and also China. And again, he's also saying high rainfall over East Asia. Okay? Of course, this is relative to this Indonesia part. Now, the question is, how good is this forecast? So on his website, he has a few pictures showing how good it is. You can judge it. This is the prediction of 2022 last year. I would say it was okay, but except for we lived in Kerala, you won't agree with this forecast. And yeah, or Uttar Pradesh and Bihar, they got the right signal, and so is northeast on the direction. Okay. One more year. This is 2019. He didn't get it right because of the heavy rainfall in Southern India in September and along the coast, and that It didn't catch. And not only that, very often I can tell you what people do. You must be very alert when you look at figures. The scale is not same. This goes 3.5 to minus 3.5 millimeter per day. This goes 7 to 7. That's tantamount to fudging, in my opinion. Okay, you should use the same scale on both, but if you use the same scale, this will look terrible. I mean, this one. You put 7 to 7 here, nothing will see. So signal is much bigger here than here. So actually, I would say it's a failure. If you look at with the right scale, it is not good. Now let's see one more. Korea also is in their business. They are forecasting, and again they are correctly saying along the equator, it will deadly failures. And so normally we have a simple hand-waving logic people use. If the equatorial Indian Ocean is weak, India should be strong. Not that simple. Because what is happening is in this model, their model, there is no almost very low rainfall over the equatorial Indian Ocean, and most of the rainfall again is hanging around the coast of India. The ITC is refusing to move to India. So this is seen in almost all the models. Notice that. Something interesting which is worth understanding. Now here is this is again Korean. This is a close-up of that. I think that's all. This is close-up. Focus made on something April. But this is May, July. This is not supposed to be. So in May, July, remember that May is going to end today. May rain all India was above normal. Okay? So that's a good news for agriculture. At least some moisture is already there. Even if the monsoon phase, there is something there. So this model shows a weak thing in May, July, and it will later on show a strong departure, I think. What is this? This is, again, I'm repeating the thing. NMMEA. This is the same thing as I showed only India. This is big picture. And this is IRI, which is multi-model, all the models put together. You can see when you add all the models, Indian situation is not that bad. Okay? So maybe I am maybe red, who knows? So we put all the model average, things sort of average out. But this is still there because this is the most clearest signal of El Nino is a drought over Indonesia. Okay? Then there are forest fires and air pollution. All those will come one after another in the next 6 months. What is the last one here? This is average of, I don't know who we should do. Average of various models here, very similar to, mostly normal. VJS. This you should buy. Control center. I can't read this. Huh? Oh, the WMO. The WMO has to play its role. You're not necessarily, they put together all the models in their own way. They can there also. Now, India has also a company other than Sky, all of you know that. It's called the Weather Company, IBM. They also put out their forecast. And so they are no different from others. All of them are showing East Asia is positive and negative in almost all the seasons here. Okay, this is, I know you can read it. This is, this is June, July, August, May, June to August, September. Very similar picture, saying that India is going to serious down. Okay, so what happened till May end? You can see clearly that monsoon was 10% above normal country as a whole in May, okay? But it will have no impact on what happened in the monsoon. They are two different systems. And how many of you watched windy, this one which is fun to watch, how thunderstorms all over India, including Ahmedabad and Ayurveda played. So that is typically the monsoon season rainfall. It's all very local. Okay? The one we had, remember, May 21, I was here at that time on a Sunday, and the thunderstorm was mind-boggling, okay, right here. And if you watch windy, it was because three plumes, one over Tirupati, one over Mysore, and one I think further on, they merged together in the afternoon. So those are very local features. Models are very difficulty in getting that right. So interestingly, if you look at the prediction of the models, both for Bangalore, predicted rainfall, in the IPL final, they all said it will rain. There's no question about that. They were right. They didn't say how much. For example, I watched the Ahmedabad forecast. They said 5 millimeters. It was 54 millimeters. So main challenge is intensity. Today, both are good enough to tell you it's going to rain or not rain, but actual amount of rain is going to be a big challenge. Same thing about cyclone forecasting. We improved a lot in the last 40, 50 years. I remember even now, 79, I was coming down from Kanpur to Bangalore after a major cyclone in Andhra Pradesh. There are 50,000 people who got killed, and I had to watch the bodies right on the other side of the track. Okay? Today, nobody dies of cyclone forecasting, cyclone disaster, because we have improved the forecast of tracking. But we can't get the intensity right. Intensity is tough. It's a very tough problem. Track is easier. Think about why. Okay. Now we come to onset of this year. This is how onset is declared by Indian Met Department. I must tell you, I'm always impressed by some of the things developed. Originally, the onset was based only on rainfall over Kerala. Okay. And you must really appreciate your people like Sir Gilbert Walker, who based on a few pressure gauges in Darwin and Tahiti, figured out the major oscillation. Similarly, Amita Krishnan, great guy, he came up with a very simple model for onset prediction of Kerala, taking enough number of stations so that it is not a local phenomena, but a large-scale phenomena. Because monsoon onset is very important because it tells you the transition from the pre-monsoon condition to monsoon condition that occurs rather dramatically over the whole region. Okay. So to use only rainfall data over Kerala to predict onset of the monsoon is not easy. So they did it only with rainfall. But today we have a lot of data on winds and satellite data a whole lot. Today we can do much better job. But the earlier one was just based on rainfall. It's quite good even now. Now here's the forecast as made by India Met Department and as actually happened. You will see that the maximum is about 5 days. In one of these places they are off by, yeah, this is the worst, for 6-7 days earlier. So their forecast is statistical, is quite good, and for the last few years, you can see last year was quite good, but this year they're going to fail badly. Why? They made a forecast of 4th June, Arindam says 15th June. I think so far Arindam is winning. Okay, but it's like a T20 game. We don't know. After 10 days, who won the match? Okay. Yeah. Right now we are somewhere here, well away from. We should be here somewhere. Around this time, but we are here. 31st May should be somewhere here. So we are lagging behind, and all the forecast shows that it's not going to move quickly. I'll see why. For example, this is the one I just pulled out from the IMD website. This is the forecast for rainfall on 10th June based on today's condition. See the IDC there, it is sitting here. Why not? In nowhere near Kerala. Okay. So we know that IMD's fortune will not occur unless there's something unusual happening. Okay. So it'll take a few more days to go from here to here. It will take 4 or 5 days, and then we'll be out by 5 days. It takes 10 days, this is what I think will happen. We'll be there. Okay. So watch this RTCC on the windy, this will become very nicely. Keep watching, there's a lot of rainfall occurring just south of Sri Lanka, and watch how rapidly it goes into Kerala. Now here's the forecast from IMD, again pulled out today, and actual rainfall. Yeah, there's some rain in Kerala, but there are not onset rain, right? Very small. Okay? I'm sure those who are in Kerala know what real onset rain is. There's not much. Now you can see that it improves a little bit coming week, but real onset is right here. Okay? That's the real onset. You can see that heavy rainfall develops suddenly. So that could be somewhere here. So Arvind could be right, or it could be 10th. One of these days it will occur. So we'll keep track of that in the coming weeks. Now, I don't like that. I want anomaly to get with. Anomaly shows beautifully how the RTC is sitting at the tip of India on the week of 8 June. And the last week prediction here shifts over here. So that's a nice prediction. There's no anomalies, much more clean than looking at the actual value. Now, why is that? Okay. Arindam again has a paper on this as to what caused the onset based on surface pressure, which is a nice way to look at it. And it shows why. I have plotted the velocity potential at 12 millivolts with the standard practice to understand where in the rising sinking motion, air is sinking over most of India, up to most of the place. And the sea level pressure is well below normal because of a cyclone in East Sea, and it's sinking everywhere else. Okay. This is a forecast, by the way. This is not. This is a forecast. This is forecast of 24th May. Okay, and it's all, that page is over. It is right. This is what is happening right now. Now, why is it happening? I have a guess. You can correct me. I find a very strong cyclone here. Okay. All the wind is now blowing toward this right now. There's hardly any wind over India. And if you at the region where we are in them, you need a strong flux of westerly wind from Arabian Sea to India to get the monsoon going. And that's not happening. That's the key thing. This could be one of the reasons. The reason I don't know. That is, you have to check it by doing many runs. But this can play a role in a scale of 1 week to 10 days. Any weather event like this can influence your onset. Onset is a transient phenomenon, not such a. What is this? This is a forecast for total rainfall valid for 1st June. Okay, you can see that according to this is whose forecast is that? GFS. You can see that it's raining over where it's no problem, and not raining over India. Okay. And what is this? This is the sea surface temperature anomaly. Okay. I want to tell you a very interesting thing here. The anomaly of SST over Arabian Sea is 1.5 degree above normal. This is the only hope for us. That because of El Nino, if the winds are not strong over the Arabian Sea, but temperature is high, there's a hope that water vapor will be higher from thermodynamics. It may partly make up, not totally partly make up, it may be not even as possible. So this is the only hope. Of course, Vinay can tell me if this is the signal of, it is not yet a signal of IOD, right? Because this is not yet come. So if it comes, maybe there's a possibility. But this is very important. You need a high water vapor content of Arabian Sea, and high winds get good rainfall. Once that is satisfied, other thing you have to check. Now, this is the water vapor content of Arabian Sea, our Indian region. Right now, you can see all the water vapor on 30th May is right south of India. This has to move here. Then we are in business. So that was because dynamical change. Notice that our East Asia already has moved. East Asia always has the early onset than India. So normally by mid-May they're all having a lot of rain. Now look at the winds now. This is the wind, mean wind, not anomaly. On 27th of May, this is what I could get, last I could get. You can see the winds are there, they're not going here, they're going this way. Okay. And until that wind goes like this, which is what is the climatology I'll show you. Sorry, climatology, let me see. Okay. Now, let me record it right. Okay. I had a climatology somewhere. I missed it. Okay, something has gone wrong. Okay. So I had a climatology which shows clearly that so somewhere here at this point it is not that, and that's one of the reasons why onset is delayed. Then you look at the 200 millibar vector at the upper level, because if the monsoon is developing properly, by now up to 15 knots we should add easily jet. Okay. That's climatology here, okay, for this day. That has not happened. We don't have a jet over India right now. So that is indication that there's a delay in the onset. And this is the actual value this year. You can see this all over the place. Only north is coming from east. So this has to flip, and that occurs very suddenly. Now this is a forecast for the next 15 days, comparison between GFS, ensemble mean, and ensemble mean. And you can see both of them are saying up to 14 June, monsoon at the most, in the case of each of them may go up to North Karnataka. In the case of GFS, did not even go that far, not in Bangalore. Okay. So this is, if true. Now we have done this kind of discussion for the last 8-9 years. We know that these forecasts are not bad. 14-day averages. So most probably will come out true. That means I don't see any possibility of June rainfall being normal. If up to 14 we are here, unless it really jumps up and pours like crazy. Second point I wanted to notice, there's a lot of rainfall in Pakistan. That's what affected the IPL match also. Now that is typical of a when the late onset, the mid-latitude systems keep coming. Okay? Remember, there's a tussle between mid-latitude systems and the monsoon, and at some point they have to push that out. It will happen. You'll watch it in a couple of days. Once it occurs, this guy goes down. Okay? Now I can tell you this is not just theory. I witnessed this personally, not in June but in October. After I'd gone trekking in 1985, okay? And we had rain everywhere in October 1st. I was really annoyed because I'd done a lot of planning. October 1st is a good time after the onset of the month, after the withdrawal of the monsoon, but monsoon didn't withdraw. Okay? It was pouring like crazy and we were all cursing, deciding we'll go back home. Within one day, monsoon withdrew and the weather changed completely. So it was such a wonderful event to see all the snow peaks when there are no peaks visible in the next day. So this phenomena of the easterly jet coming here and pushing that out, and on the way back, the westerly jet coming down is very, very dramatic, nonlinear phenomenon. And so this could be connected to the kind of what Rajat is doing about how jet transients move. Okay, this is a forecast for next 7 days. It looks okay, but it's still below normal. Now here is the final graph. This shows the orange number and river. Also always show this because it's a simple number to look at. This is the orange number river till the 10th of June according to GFS. Based on today's condition, there is no chance of rain till 10 June. You should be here. 4.5 millimeters, we are at 1.5. So definitely first 15 days of June is going to be well below normal. And so the prediction of 93% rainfall zone is ruled out. The onset date definitely is wrong. And my gut feeling is prediction of normal rainfall for the whole season is also wrong. That's my prediction. Okay. Now you might wonder, onset delay due to NGO. We discuss NGO all the time in this discussion. Not true. This time NGO is very weak within the circle. I don't think NGO is playing a role right now, but NGO is going around somewhere here. So it may strengthen and may help the onset. Who knows? Next week we will know whether the onset is triggered by NGO coming around all the way across the year. Okay? It may happen. But right now it's not contributing to the delay. Okay, thank you. Okay, nobody announced who will be next week's speaker. Next week we have a visitor will give a talk, same time date. So next meeting will be in 14 June, right? And it will be who will be that? Ritesh Shah, right? Yeah. Okay. So any other question?
So the tropical easterly jet which is not forming right now. Is it because of the cyclone which is there? Because its vertical extent is the cyclone's vertical extent is
I don't know. My that we tropical extent has a much bigger phenomenon. Cyclones should not affect. I don't know. That cyclone is quite big, not normal. It could be all the way. So one has to look at. You look at it, is it that in a normal year or at least grows? And this year, if it stopped growing around the second year, it got the velocity of the jet starting from like 15 May to today, and see the growth rate of the jet. Let's go rapidly. If it stops growing because of the second, then you could be right.
Actually, it has become weaker in the last 2 years. That tropical easterly, it has become weaker in the last 2 years. It was more easterly, it has become close to neutral.
Oh, so the second is some has been coming. Yeah, but cyclones are very low phenomena, but bigger phenomena. You normally think a small guy will not, the is not going to talk, but you don't know. You cannot be. If it is in the phase of accelerating the jet, something happens. I can tell you, every couple of years we get a, I'm sure Ravi has seen right here, we get a letter from our members of parliament To tell us why can't you kill a cyclone right when it's forming? Right when you put a new philosophy. The answer is you can't. The cyclone is very, very strong. It has an energy capacity of 10,000 megawatt power plant. Okay? You cannot touch it. But right before the cyclone starts, if you know it, we don't know it right now. We know it, there may be some way to disrupt. Say that water is disrupted, yes, you could do something. But once the water grows, no human activity can operate. I've got Americans put a lot of money on it. How to kill a cyclone? By putting aerosols in this, that. Nothing has actually resolved. I mean, I'm talking about modeling. Nobody actually done in the real world. So the fact is that these systems are very big. They're not able to get manipulation or anything. Yeah.
So the extent is related to rainfall that is going to make. Easterly weakening of easterlies. Related to rainfall that happens in the next month.
I don't know. What's the main system? They are not monsoon rainfall. They're all thunderstorms, one after another, or individual, right? I don't see that having any effect. I don't. Yeah, who are thunderstorm? We are expert thunderstorm here. You can tell us whether there is a very clear. Can you tell me whether wind at the upper or has any effect on thunderstorm?
So I don't think it that much large scale.
You guys said a lot of wind thunderstorms, right? Affect a lot of them.
Yeah. And
I don't think this is a nuisance. Although I don't think it's although I think what happened is because of the long partner nuisance, I'm sure. Well, in the east you know that we all the time and so in Bangalore, but I was surprised in Gujarat that